We have simply supported beam. The length equal 10 feet. The cross section is given 14 times 22, and the reinforcement, the F prime C 3,500, F yield 50,000. The beam supports a concentrated live load 50,000 pound. This one is 50,000 pound. It's a live load. It's a live load. And we have dead load, how much? 12 pound per foot. If the stirrups for this beam is number 3, can you tell me what is the spacing between these stirrups? As you know, guys, from last time I told you we have two factors. Do you remember? To design stirrups, we have two parameters. Just a second. I have space. Yeah. We have two parameters. The first parameter, what is the bar size used to make your stirrups? There is a stirrup. What is the bar size? And second parameter, spacing. S. So we have another stirrup, we have another stirrup, we have another. So what is the spacing between each stirrup? So we are going to assume one of them to figure out the second one. The most efficient way, we are going to assume the bar size. We have two options, number 3 or number 4. 99% or 95% for the stirrups in our structure, concrete structures, made from number 3 or number 4. Then we can figure out the spacing between stirrups. In this problem, we didn't give you a chance to select the size. The problem said, hey, go ahead and select number 3 stirrups. So we are looking for what is the spacing between stirrups. Largest size will be number 4, probably number 5, but in very special structures like frames or something like this. If you have earthquake category or something like this, because you know the issue. What is the issue? What is the issue if I used number 10? Do you know what is the issue? Anybody know what is the issue if you are using larger size for stirrups? Can you expect what is the issue? Weight? No. Too heavy, it's not a big deal. Too thick. Too thick. If you go outside for any site and you are looking for what is the size of your bar, we have these sides. It's very easy to deform these small size as you go back to the actual shape of your stirrups. Yeah, here you go. Can you watch this one? We are looking to deform the bar to take this shape, rectangular shape. Probably if you have large size of bars, probably your bars will be broken if you make this right angle triangle or this right angle. So we are looking for bars that we can deform them to make your stirrups. Number 3, number 4 are more practical. If you go up for number 5 or number 6, probably you will have issues to deform the bar to this shape. This is the issue. This is the only issue. Okay. Yes. Yep. Burak has more experience with practical engineer, I believe. Okay, so guys, first step, we need to figure out what is the value of ultimate shear. So we need to go back to structure analysis. To go back to structure analysis, you have to put your hands on what are the loads do you have. We have given live load, concentrated load. We have a given dead load, uniform distributed. But remember, the on weight is not included. By the way, on weight most of the time not included, even until the problem saying this. If the problem said the on weight is already included in the given dead load, then forget it. But if you read this problem or any other problem, no, nothing is mentioned about on weight, so we have to figure it out. The on weight of this beam, do you remember? How can we figure it out? Yeah. 14 divide 12 time 22 divide 12 time 150. Guys, we have a story behind this equation. B divide 12, T divide 12, gamma concrete. That's right. So I can figure out the weight of the problem. I'm sorry, the weight of the beam. So 14 divide 12 time 22 divide 12 time 150, it will be 320.8 pound per foot. So the total dead load as a distributed load will be this value plus the given value, this given value for something else. We don't care. So plus 12, it will be 332.8 pound per foot. Any questions so far? Any question, guys? Okay. So one by one, for dead load, we have uniform distributed load, and this uniform distributed load is a dead load. So your final dead load will be 1.2 times 332.8. Go ahead and multiply this number by 1.2. It will be 400 pound per foot. We have concentrated load. How much? It's 50,000. It's a live load. It's a live load equal 50,000. So we need to multiply this number by 1.6. So this problem is different a little bit because the dead load is given as a distributed load and the live load is given as a concentrated load. Actually, it's not a big deal. 1.6, it will be 80,000. What is the reaction here? What is the reaction here? Your reaction in this live load case will be 40,000 pound. Do you agree? Yeah, we have a beam with concentrated load at the midspan. That means half of this beam or half of this load will be on this side and the other half will be on the other side. If you can make equivalent for this distributed load, it will be 400 times 10, which is 4,000. So half of them will be on this side, and the other half will be on the other side. So your reaction as a dead load, V ultimate as a dead load, and V ultimate as a live load. So your V ultimate as a total will be 2,000 plus 40,000. It will be 42,000 pound or 42 kips. If you have any question, let me know. If you have any question, let me know. Just to give you a hint, if you have a beam with distributed load, you need to make equivalent for this distributed load. Half of this equivalent load will be at the reaction here, and the other half will be a reaction here. If you have a simply supported beam with one concentrated load at mid-span, your reaction will be half this value, and the other reaction will be the other half. You have any comment? Okay. So my calculations on weight, this on weight plus the given dead load and the given live load, I can figure out the value of V ultimate. Anybody remember the second step? We have some steps here. First step, we need to figure out the value of V ultimate. Second step, go ahead and calculate the design contribution or the design shear strength of concrete. Do you remember? VC equal, I think 4 B web D square root F prime C, as I remember. That's right. VC, I'm sorry, 2 B web D, not 4, 2. Okay, 2. What is the value of B web for this cross section? 14. What is the value of the depth? 22 is the total, the overall depth, but 18 is the actual depth. So 18. What is the value of F prime C? It's given 3,500. So I can figure out the value of VC, 2 times 14 times 18 times square root for 3,500. So your final answer will be 29,817 pound. If you convert it to kip, we don't like this large number, so I convert it to kip. It will be 29.8 kips. But I'm looking for Phi VC. We don't need to search for what is the value of Phi, because value of Phi for shear 0.75 times 29.8. This number will be 22.3 kips. We have 3 situations. We have 3 situations. The first one, V ultimate smaller than or equal Phi VC divided 2. The second situation, V ultimate greater than Phi VC divided 2 and smaller than Phi VC. The third situation, V ultimate greater than Phi VC. What is your situation? What is your situation? I think V ultimate, what's the value of V ultimate? 42. Phi VC 22.3. That means you are in the third situation. Remember, if you are in the first situation, no stirrups. required. If you are in the second situation, we have a value for S. You can figure them out. You are in the third situation. That means we will look for VS. Do you remember what is the value of VS? Equal V ultimate divide phi minus VC. V ultimate 42 divide phi 0.75 minus VC, not phi, VC 29.8. So value of VS will be 42 divided 0.75 minus 29.8. It will be 26.2 kips. If you go back to your equations, VS equal area V, I think F yield, I think D divide S, I believe. Just a moment. Yes, we are good. So guys, your stirrups will be, looks like rectangle. So how many legs do you have? 2 legs. And the size is number 3. That's right. So the area V will be how many legs? 2. What is the bar size? 0.11. So your area will be 0.22. So area V 0.22. F yield, what is the yielding strength for stirrups? 50,000. Your depth 18. Your value of VS 26.2. We have a mistake here. We have a mistake. From this equation, I can figure out the value of S, and I will give you the value. But we have a mistake. Anybody can tell me what is the mistake here? Thank you, Oliver. Thank you. Thank you. Guys, if you watching the units for the right side of this equation, this depth in inch, this area in inch square, this F yield 50,000 PSI, which means pound per inch. And this spacing will be in inch. So everything on the right side in pound and inch. That means on the left side must be pound and inch. Actually 26.2 in kips. So I have to multiply it by 1,000 to get a realistic number. So your value will be 0.22 times 50,000 times 18 divide 26.2 times 1,000. This number equals 7.6 inch. So the spacing between stirrups in this beam must be within 7.6 inch or smaller. You cannot exceed this number. If you would like to make sure this number within the less than the maximum spacing, this number must be less than the maximum spacing which is permitted by ACI. So we have here a conditions. Check on the maximum spacing. We are not in this case. We are in this case. So please go ahead and figure out you are in this one or this one based on the relation between VS and this expression. If you are in this case, so the smallest or the maximum spacing will be D divided 2, which is 9 inch, or 24 inch. I'm going to use 9 inch. How can I figure out 9 inch? Your depth. The depth in this problem is 18. Divide 2 will be 9 inch. So I believe 7.6 is smaller than the maximum spacing, which is 9 inch. So you are good. What will happen if the required spacing, for example, equal 12 and the maximum permitted spacing equal 9 inch? So I'm gonna say, no, the maximum space, I'm sorry, the spacing between stirrups will be 9, and I will forget the value from your calculation. So please pay attention that your spacing must be smaller than or equal the maximum permitted spacing. Any question? So as you see, design is only steps. You need to follow these steps. And you need to remember and be organized. Which equation I'm gonna use, which situation you are in. So for shear, we have 3 situations. And remember, this first step is very important. Loading and structure analysis to figure out the value of V ultimate. Then you are in this situation or this one based on your value of V ultimate. Any question? Guys, any question? If you have any question, let me know. Okay. We have another internal forces that we didn't cover in structure analysis, but I believe you should learn a little bit about it in mechanics of material, which called torsion. I would like to be sure you understand this point correctly. If you have a beam like this, and you have here 3 axes, one called X, and one called Y, and the other one called Z. If you have a moment like this, do you know this moment is rotating about what? Which axis? This moment is rotating about which axis? What do you think? Thank you. Thank you. This moment can be called mx. So we have a moment on this cross section making a tension on this side, so we need reinforcement, and making compression on the other side. Perfect. What this moment, if you have a moment like this moment, I need to change the color. If you have a moment, which color? Okay, let's try this one. Moment like this. This moment is rotating about what? Y? Yeah. So we can call it My. This moment will make tension on this side and compression on the other side. That means your cross section has something called biaxial moment. Anyway, so we have a moment about X, we have a moment about Y, which is the regular moment. But what will happen if you have a moment like this? This moment is rotating about what? Z. Perfect. This is called MZ. Let me define you this moment a little bit. It's a moment. It's still a moment. This one is moment. And this one is moment. And this one is also moment. So all of them are moment, rotating. But the last moment is rotating about Z. Or in a different word, moment rotating about the longitudinal axis of the member or of the beam. Oh, longitudinal axis? Yes, I'm talking about the axis in the longitudinal direction of the member. And this moment is rotating about this axis. In this case, this moment can be called torsion. This moment will rotate your beam. Guys, the regular moment, which is mx and my, will be supported by longitudinal reinforcement, which is area steel, like we learned before. But if you are thinking or try to understand this moment would like to rotate this beam, so which reinforcement will support this action? Which reinforcement? Actually, it will be stirrups. These stirrups will support this action. It's special stirrups. These stirrups must be closed stirrups. I'm sorry, what do you mean by closed? Closed. Like this. If you can weld these ends, that will be fantastic. Because your stirrups cannot be like this. This one is good for shear, for V ultimate. Or like this. This one is good for shear, V ultimate, like we covered early today or last time. But if you are talking about torsion, no. If you put this one in the torsion, due to this action, the stirrups will be opened. So your stirrups must be closed stirrups. It's special stirrups. So I can conclude this information. If you are talking about shear, V ultimate, if you are talking about torsion, which called T ultimate, stirrups will support both of them. But for shear, your stirrups can be open. You can be open like this. That's fine. But for shear, no. Your stirrups must be closed stirrups. Must be closed. If you can weld this end, that will be good. Any question for this point? The most important thing for me and for you to understand this concept. Because solution, it will be just steps. Nothing. Nothing. But you need to understand. Guys, we have 3 types of moments based on the direction or the axis of this rotation. By the way, I will not say mx and my are normal moment and mz all the time is torsion. I will not say this. Guys, you have to be more professional. If you have a beam, and let's assume this one is X, this one is Y, this one is Z. So I don't care which one is MX, which one is MY, which one is MZ. My concern is which moment rotating about the longitudinal axis of the beam. In our situation right now, your longitudinal axis is X. So MX will be your torsion. So keep it in your mind. The moment which is rotating about the longitudinal axis will be the torsion moment. Any other moment is a regular moment, can be supported with the regular reinforcement. But for this torsion, we need to add special stirrups. I mean by special, closed stirrups. Anybody has any question for this point? Do you have any question for this point? Okay, let me show you some cases. Your beam will be under the effect of torsion. Can you look to this one? We have reinforced concrete column, and this column supporting a beam. For any reason, probably you have a swimming pool and you will stand here to jump in the ball, for any reason. We have a slab. This slab is cantilever supported on this beam. What do you think this slab will do for this beam? What's your expectation? I believe this slab with its own weight, and for you standing here, will try to twist this beam. That means this beam will be under the effect of torsion. Do you agree? If you don't agree, let me know. Yeah, thank you. I don't care about the column right now. The column will be covered next week. The column will be covered next week. I don't care about the column because the column will be under the effect of a moment. We will talk about it next week. Many different situations for columns will be covered. Don't worry. Okay. What about this one? The same concept, but in a different way. We have a beam supported by this column and this column, and we have a short beam coming out. For any reason, we have something supported here. So we expect on this beam, the original beam, torque, torsion, twisting. Or we have a beam looks like inverted T. Can you see? Inverted T. This beam is extended to this side. For any reason, we have another beam supported here, and we have another beam supported here. If the two reactions are equal, nothing will happen. But for some reason, we have here a reaction R1, and we have another reaction here R2, are different. This one is bigger than this one. So the different reaction will make this beam to twist. If you have a curved beam, and you have vertical load, this vertical load will make twist or will twist the beam. Or you have 3D beam. So this concentrated load by this arm will make this beam to rotate. So we have different situations that we can find torsion. You have any comment, any question? You have any comment or any question about torsion? Okay. So we have stirrups. We need to put stirrups in this beam. and this stirrups must be closed stirrups. We need to add stirrups to this beam. These stirrups must be closed, and we need to figure out what is the spacing between these stirrups, what is the size of this stirrups. That's it. It's very easy. Very easy. Guys, remember I told you this torsion is a moment, which means force time distance. So it's not a special internal force. No, it's a moment. But this moment is special a little bit. Why is it special? Because this moment rotating about the longitudinal axis. We have few steps. The first one, we need to check if we can neglect this torsion. It's not large enough, so we can neglect it. Forget it. We have the same situation in shear. Do you remember? We have the same situation here. If V ultimate is smaller than or equal phi VC divide 2, neglect. Shear. Neglect means no stirrups are required. Forget it. It's very small. Ignore it. The same situation here also. You can check. Probably the torsion is very small, so we can neglect it. If T ultimate means the ultimate torsion. Smaller than or equal phi. Anybody can remind me what is the value of phi? For shear and the torsion, the same value, 0.75. Square root F prime C, area CB square, divide P CP. Lambda will be 1 all the time because we are talking about normal weight concrete. Normal concrete. So we don't care about this term. Area CB and area BC. Area CB is the area of the total cross section. The whole cross section. The area of the whole cross section. H times B. B is the width. H is the total, the overall depth. P, perimeter. What is the perimeter of this cross section? Perimeter means B plus H plus B plus H. So H plus B times 2. Do you have any comment for the first step? Probably your torsion is smaller than this value. That means we can ignore this torsion. We can neglect this torsion. Thank you, guys. Second step, we need to check. Probably your cross section as a concrete is not enough. We need to make sure your cross section is large enough, because the concrete will contribute in this resistance. So we have expression here. V ultimate, if you have shear. If you don't have shear, this term will be neglected. Because sometimes you have shear and the torsion at the same time. Your problem under the effect of different loads. So you have shear and the torsion at the same time. If you don't have shear, neglect the first term. But if you have shear, you have to consider it. V ultimate divide B web times D square, all of them square, plus T ultimate PH divide 1.7 AOH square, all of them square, must be smaller than phi times this expression. By the way, phi equal 0.75. We have some expressions here are new. What is the value of pH? What is the value of area OH? Just to give you a hint. Guys, we have here area CP, PCP. You are talking about the whole cross section for area or perimeter. But in the second case, we are talking about something different. We are talking about, can you watch if you are drawing something at the center line of the stirrup? I'm drawing a line at the center line of the stirrups. Can you watch? At the center line of the stirrups. The area inside this shape can be called area OH. And the perimeter of this shape can be called pH. So in a different way, the distance between this center line and this center line of the stirrup will be called X1. How can I figure out the X1? X1 will be the total P minus 2 time cover plus stirrup leg diameter. If you subtract this cover, and we have another cover here, so we multiplied it by 2. And you are talking about center line. Hey guys, can you watch me, please? The actual stirrup looks like this. This is the diameter of the stirrup. That's right. We are talking about this center line. And here is the cross section. So the total width is B of the cross section. I'm talking about this distance, which called X1. So if you would like to get X1, X1 will be B, the total width, minus this distance and this distance, which is cover time 2 minus this little distance and this little distance. Can you tell me if you add this one plus this one, what is the value? It will be diameter of the stirrup. Because you have radius here and you have radius here, that means if you add this one plus this one, you will get the diameter. Do you have any comment? Okay, looks good. The same also for Y. If you would like to get the Y1 distance, it will be the total H minus. We have cover here, we have cover here, we have half diameter, we have half diameter, so your Y1 will be like this. If you multiply X1 times Y1, which is the area of this shape, it will be AOH. If you add this side plus this side plus this side plus this side, you can get the perimeter. So this term and this term can be figured out. If you check this expression and it's okay, your cross section as a concrete will be good. Nothing, you don't need to do anything else. So please, before starting to figure out the spacing between stirrups or design of stirrups due to torsion, we need to do 2 checks. The first one, do you think we can neglect this torsion? Do you think the concrete cross section is enough? This one If this one is okay, neglect torsion and stop, and you can say we don't need any stirrups. If this one is okay, go ahead and keep going because your cross section is good as a concrete. So the following step, how can we design the stirrups required for torsion? And I will cover this next time. Guys, I would like you to understand few concepts from this topic. The most important concept, what is the meaning of torsion? What is the difference between torsion and the regular moment? Actually, both of them are moments. Both of them are force time distance. But your torsion is a moment, is a special moment rotating about longitudinal axis. The regular moment will be supported by longitudinal reinforcement that we covered before exam 1. But now the torsion, which is a moment about longitudinal axis, will be supported by closed stirrups. If you have torsion, your stirrups must be closed. Must be closed. If your stirrups are open like this, like U shape, or like this, or any shape which is not closed, during the torsion, your stirrups will be opened and the failure will happen. So your stirrups must be closed. We have few steps in design. We talked about the first two. You have to check if the torsion can be neglected or not, and if your cross section is large enough or not. Hey guys, if this expression is not verified, that means your cross section as a concrete is not enough. We have to increase it. If this happens, if this left side is not smaller than or equal the right side, that means your cross section as a concrete, I'm talking about B and H, the cross section dimension, are not enough. You need to increase them before design. Any question?